All right, so we were talking about acid in water and base in water and pH. And so we're going to continue with base in water right now. So here we have a base in water. And so in this case, the water is acting as an acid. It's giving up a hydrogen ion or proton to the NH3, causing it to form its conjugate, NH4 plus ammonia, and ammonium ion, and also hydroxide ion. So here we have a base in water. And when we're talking about a base in water, we're going to talk about a base ionization constant, or Kb. So at the end of last class, we talked about the acid ionization constant, or Ka. And when you're talking about bases, you're going to talk about Kbs. So Kb, it's an equilibrium constant for this reaction of a base in water. And so it'll be equal to the products, NH4 plus and hydroxide ion, over the reactant, NH3. The water is the solvent here, and since this is all pretty dilute, it's mostly pure, and its concentration isn't going to change, so it's not included in that equilibrium constant. So we have a Kb when we're talking about a base in water. And when we're talking about a base in water, the equation should work that you have hydroxide ions on one side of it. So here the Kb is 1.8 times 10 to the minus 5 at 25 degrees. So that's a fairly small number. And so the small value tells us that only a little bit of the NH3 is going to ionize when it's in solution. So only a little bit is going to form NH4 plus and hydroxide ions. So that's what that small number tells us. So that tells us that it's going to be a weak base. So a strong base is something that's going to react pretty much completely to go to hydroxide ion concentration. A weak base only ionizes a little bit in water. And you can tell about whether something's strong or weak by its Kb value, or if it's an acid, its Ka value or pKa value. So here are some general ways to write these equations. We have a base in water. And so the water is going to act as the acid. Base is going to accept that proton or hydrogen ion, forming a base H plus and hydroxide ion. So the base is just written as B. You could also write the base as A minus, something A minus in water, going to HA plus hydroxide ion. So sometimes you might see that when you're talking about a conjugate base of a weak acid. So these are two expressions that you'll see that are fairly generic that expresses what happens when you have bases in water. Now remember, you know it's a base in water. You better have hydroxide ions on the other side, because a base in water is going to be forming hydroxide ions. An acid in water would be forming hydronium ions. So a strong base, again, gives you almost completely ionizes to OH when in water. And here we can know what's strong or weak by the Kb. So the larger Kb, the stronger the base. And like there is the pKa, there's also a term pKb. pKb is minus log of the Kb. And the larger the pKb, the weaker the base.